Whether my voice is audible?
Yes, sir. Yes, sir.
Okay. So I welcome you all for the this new lecture about the wire cut EDM and our related discharge machining. Firstly, we'll go through the some videos. Then we'll see the differences and similarity between die sinking EDM and wire cut EDM. Okay. So here I have some videos. Now I will start from my system. Please give me a feedback about the that visuality of the this videos and the voice. Okay, whether voice is audible to you or just only that screen. Screen दिसते का बा?
Sir.
एक मिनिट. I think screen I have not share. Oh, okay. One minute. I forgot. Okay. I think voice is not audible to you. Correct?
Yes, sir. Yes.
Yes, sir.
Uh, you can just see no problem because this through this Google Meet it is difficult to see your voice. Okay, I will explain. No problem. Firstly, we'll go for the that this animation video regarding the working principle of electric discharge machine. Okay, so just start. Now, as we know that for the EDM process, we require the tank, and in that tank, we should have the bacon. Okay, that direct fluid here they have taken as a kerosene. Okay, kerosene as a direct fluid. Then, as we know that we have to immerse or submerge our workpiece in that direct fluid. So you can see there our workpiece is there. Okay, which will act as a anode, that is positive terminal of the DC supply. It is connected to the workpiece. Okay, then to pass or to circulate that dielectric fluid, we should have the pump, then filter system, and to flush that dielectric fluid, we should have the nozzle. Okay, then we should, the main component is the our tool. Okay, and that tool is a electrode because it is connected to the negative terminal of power supply, so it will act as a cathode. Can see, and the material of the electrode here we have used, that is graphite or copper. Okay, then we have to give the feed. Correct. So for that purpose they have shown one arrow about the feeding. Okay, now the most important, that is electric energy supply. So for that purpose DC pulse generator is used. So during the that EDM lecture we have gone for the all the elements. Okay, so this is just the revision or a recap about that. Now we can see how we can flush the dielectric fluid between the interelectrode gap. Okay, so they are showing like that. And flushing of that dial fluid, there are different modes or methods that also we have studied. Okay, central, then side also. So these all are the elements, and this total is a setup of our electric discharge machining process. Okay, already we know that this. Ah, now we have the another video about this electric or electro discharge machining. You can see whether video is visible to you.
Yes, sir.
Hello. Okay. This is a schematic diagram of PDM. We know that same things. I think still voice is not there. No? One minute. You can see how our machine table or that work is table, how we can move in the x and y direction. Okay, and how we can give the feed to the servo mechanism system, to the that feed we have to give to the our tool. Correct. One side I'm showing the schematic diagram of this setup, EDM setup, and other side we can see uh, animated setup, okay, with 3D component or elements. So this type of setup, uh, with a minimum component, we can go for our at our department also. Okay, you can just note down the which are the minimum requirement of the machine, and that from that parts you can develop our own EDM machine. Okay, and again you can go beyond that. The media that EDM machine should have the capacity of the accuracy up to the micron. Okay, so you can say micro EDM machine you can manufacture or you can develop. Okay, because in our department or at our institute we not still date till date nobody has developed the such machine. Okay, if you see in the COP Pune, then WC Sangli, at there again they have the this type of setups. Okay, but for our college we can go for this, we should have that. Now we'll go for the another one. Now this is the industrial application. Okay. Now you can see the workpiece, it is already submerged in the dilute fluid, and this is a tool. Okay, having shape as a replica of the desired shape that which we want on our workpiece. Okay, and you can see how the spark is generated. Okay, how that electron and ions particles or molecules transformation happen between that inter-electron gap. It's a enlarged view they have shown here. Okay, plus means what? That is a anode. Okay, and minus means what? Our cathode. Or if you change that polarity, we know that normal polarity we are using. That means positive terminal to the workpiece and negative terminal to tool. Now you can see here also how the spark generate in between that interval gap or in between that tool and workpiece. Okay, and that column is called ionized column. Correct. And after melting, that evaporation happen. Correct. Now you can see how the manufacturing of gear is carried out using our electro discharge machining. You can see this is a EDM process. Using this EDM process, they are manufacturing gear. That flushing, that water you are seeing, no, that liquid, that is a direct fluid. Okay, and now you can see sparks are generating there. Okay, and that is the water gap we are observing. No, that is interelectron gap, and between that gap or in that gap, spark it is generating. Whether video is visible, Saurabh Dotre, Saurabh Dotre.
Yes, sir. Yes, sir.
Okay, Amol Mari, whether are you watching this video? Amol
Yes, sir.
Mari.
Yes, sir.
Okay. Another one, gear cutting. Okay, but using wire cut EDM process. Wire cut process. You can see. This is our wire. Okay, तुम्हाला mouse दिसत असेल माझं cursor. And this is a workpiece. Just that person has mounted that workpiece. Okay, this is wire. These are the wire guides. You can see here. Now he is that mounting properly that workpiece. Okay, and then after that mounting, he will go for the positioning. Okay, and the positioning will be carried out using the uh, computerized numerical controlled position system. You can see also. Okay, they have shown that. that positioning is going on. Now here, now you can see wire. Okay, from take up reel, you will take wire, then it will go to the that next reel. Okay, at output end. Reuse of this wire is not permitted for this process. Already we have discussed in the last lecture. Very small diameter is there for this wire, maybe around 0.15 to 0.30 mm. Okay, and normally brass wire is used, brass material. Okay, these are called take up reel. You can see here reels are there. Now these are the guides. You can see here guides. So this is called bowing of wire. Last time I was explaining this point. Bowing of wire. Okay, we have to give the inclination to a wire like our Dhanushyaban. Okay, in Marathi we know that. Now after positioning, now they will start the operation. Okay. Now which shape they want that cutting of the gear. Now for this particular video, gear cutting operation is there. So about that, whatever desired shape they want, no, about that the command already has been given by that numerical control system. Okay. Accordingly, that command we will get the shape. Okay. Uh, Now you can see. Firstly, we have to submerge our this tool as well as that means wire as well as our workpiece with the dilute fluid, that is a deionized water, and you can see. And once you will start that pulse on, that means the supply of the electric energy, then spark will generate in between the interrelator gap. Interrelator gap means what? The gap between your wire and your workpiece surface. Okay. Now you can see there spark is happening. Okay. And due to that spark, metal removal will start. Okay, with the help of with the melting action. Okay, and as well as partially vaporization. Okay, so you can see now here. Okay, now we got the gear. Okay, the external gear. You can see how the shape is machined, or you can say manufactured using this wire cutting process. Our remaining part again, positioning and all these things, adjusting, and then they will start. So these are the advanced machining processes. Okay, our title of subject is same. Advanced machining process, or you can say non-conventional or non-traditional machining processes or machining. Whether these videos are understandable, Okay, I think you understood whether these videos are understandable. Okay, Abhinay. Okay, I will go for the next one. Now we'll see the animation video of the wire cut idiom. Huh? Now, very soon you will get this type of animation video from my side also. Okay, I also started to prepare this types of animation video. You will get very soon. Okay, please try to convert the theoretical knowledge into the practical things or for the research or for the your project, because our subject will give many opportunities or the ideas for your research or your project. Another video regarding wire cutting process for the champering purpose. Okay, this is your workpiece. Correct. You can see now here. Using wire cut idiom process, champering is happening. This is your workpiece, and this is your you can see wire is there as a tool for the champering purpose. They are using the this wire cut idiom process. See, direct fluid. And now you can see yeah, that sparks are occurring at there in that gap. Okay, and due to that melting and the vaporization, you will get the you're observing that some bubbles are creating. Okay, in that fluid. Now you can see how that material is removed. Okay, there chamfered. You can see. They have stopped that process. Then they have gone for the adjusting that workpiece. Okay, and then they have once again they have started. You can see how the spark is generated. There is no physical contact between your electrode, that means your wire and your workpiece. Okay, there is always a small gap that is called inter electrode gap. Now you can see the machinery that workpiece. Okay, you can see this type of shape is generated. Okay, that we got on our workpiece. Okay, you can see. Again, adjusting of the workpiece. Okay, positive terminal of your that power supply, it is connected to the your workpiece. Okay, once again I repeat, and the negative terminal, it is connected to the your wire. Okay, so due to that, your wire will act as a cathode and your workpiece will act as anode. What are your looking on this upper part? Okay, where you are getting the wire, it is called take up reel or guides, wire guides. Okay, now once adjustment or that positioning of wire happen, no, then supply of that dielectric fluid will start, and then uh, circuit will start. Okay, whether it is interesting, ह्या व्हिडिओ मधून तुम्हाला काय म्हणजे आतापर्यंत जेवढं असेल त्यात थोडं जर समजलंय नाही बघा, थोडं तर. मदन पाटील, मदन मदन पाटील, मदन, से येस ऑर नो. लेक्चर मध्ये आहेत का मदन? नानासाहेब शिंदे, नानासाहेब, वेदर आर यू इन दिस मीटिंग? सौरव वाडेकर, शुभम देवकर.
Yes, sir.
हा, ओके ओके, थँक्यू. रोहित विदाते, रोहित. Now, now what are you are watching on that? Now it's at that our conventional champion. Huh? Okay. Oh, अच्छा. Now shall we move for further part? Shall we see that difference between the dielectric, sorry, die sinking idiom and wire cut idiom? Why this is not happening? 1 minute. From my PC, I will share my screen. 1 minute. हॅलो. हा, आतापर्यंत कुणाला काय डाऊट? पुढच्या पॉईंटात जाऊ द्या का?
Yes, sir.
Okay. Quickly we'll go for the that similarities and differences between the die sinking and wire cut idiom. Already about this point, today morning I have released that video. If you have not seen, if you have not watched that, please watch. Okay, tonight, no problem. Okay, so now we'll go for the new point, that is similarities and differences between die sinking idiom and wire electric discharge machine, that is a WEDM. Okay, already during my last three lectures we have gone for this all process. We know that what is meant by electric chair machine, how it works. Okay, so directly I will come to the our point. So firstly we will see similarities between the die sinking idiom and wire idiom process. Okay, so as we know that both this die sinking idiom and wire idiom processes are thermal energy based non-traditional machining process. Now, in some book or in some online courses or the in website also, they are saying it is electric energy based non-conventional machining process or thermal energy, but actually it is thermoelectric energy based process or electrothermal process, because here we are using both the energies. Okay, as per our syllabus, this EDM process comes under electric energy based process. Okay, thermal energy based process, uh, that chapter it is having different point, but this EDM process belongs to the electric or electrothermal energy. Okay, or thermoelectric. Okay, then what are the mechanism of material removal is there? No, for both the cases is same. Okay, as well as what are the suitable dielectric fluid is required? No, like kerosene or deionized water. Okay, so for both the cases again it is same. Okay, it is applied. Okay, dielectric fluid, suitable dielectric fluid is applied for or in both the cases for what purpose? To assist the spark generation and debris removal purpose. Okay, so these are the similarities. Again, the presence of suitable potential difference between the your tool, presence of suitable potential difference between the your tool electrode, that means the cathode, and workpiece, that is anode, is indispensably necessary for breakdown of dielectric fluid. Okay, so here for both the processes there should be suitable potential difference. Okay, which will be greater than the breakdown voltage of dielectric fluid. We know that if our that capacitor potential difference of the voltage, okay, it is greater than the breakdown voltage of dielectric fluid, then and then only spark will occur. Okay, then none of these two processes or none of them is associated with the production of burr or residual traces. For both the cases, no burr formation, no production of the burr or residual traces. Then none of them release on mechanical properties of workpiece or work material. Okay, here we should know, we don't have any problem regarding the mechanical properties of the workpiece, but here limitation of the condition is that electrical conductivity should be there for your workpiece. Okay, so electrical conductivity is one of the mandatory or compulsory properties of your workpiece. Okay, so these are the points about the similarities. Okay, दोघात साम्य काय आहे, साधं simple. Now we'll see the differences between the die sinking idiom and wire idiom. Okay, now in our syllabus we don't have the separate point in the syllabus like the difference or other, but after studying the die sinking and wire cut idiom, you should able to differentiate both the process. For that purpose I am taking this point. Now uh, you can see in my on your screen or in my presentation I have made the two columns. Okay, in one column you will get the points regarding the die sinking idiom, and in the second column you will get the points regarding the wire cut idiom. So point number one about the die sinking idiom is that in this die sinking idiom process, is die is made up of the conductive metal. Okay, and that die will be act as your tool electrode, that is cathode. Okay, for what purpose? To liberate the electrons for producing the spark. In case of uh, wire cut idiom, here instead of die, a small, a small diameter wire made up of the conductive metal like brass is used as a tool electrode or your cathode. Okay, then in case of die sinking idiom, die can be given complex theoretic profile. Then accordingly, die sinking idiom can produce integrate shapes and features on the job. Okay, but in case of wire idiom process, here wire always have some simple geometry. So wire idiom is not suitable for producing uh, 3D counters or 3D shapes. It is preferred for the only 2D cuttings. Okay, then die sinking idiom, it can produce blind features like holes or cavity that are not open in bottom end. That means the uh, wherever we have to go for the machining of complex geometries or complex shapes or cavity. For that purpose, we can go for the die sinking idiom. But in case of wire idiom, it cannot produce any blind features. It is applicable only for profile cutting, just like our gear cutting by means of through holes only. Okay, that means if you want to go for the slot purpose, then you can go for the wire cut idiom. Then next point is that die sinking idiom can start machining at any location on the workpiece. Okay, die sinking idiom process can start machining at any location on the workpiece, irrespective of presence of or absence of edge or throw holes. But our wire idiom process can start machining from edges only. Okay, and to initiate wire cut idiom process at an intermediate location on the workpiece, then a through hole or the starter is required for what purpose? To fabricate, okay, using other operation for the passage of wire. Okay, firstly we should have the some slot or the some through hole, then and then only we can start intermediate operation, okay, or intermediate machining using the wire cut idiom. Then die sinking idiom is commonly used for the 3D countering, finishing purpose, then drilling and deburring purpose. Okay, they are the application. But you can see in the wire cutting idiom process, it is mostly used for the high accuracy profile cutting, then sample preparation and separating or the parting of or slotting of purpose. Okay, so these are the points. That means the differences between the these die sinking idiom and wire cut idiom process. Okay, and whatever I have told just now, what are the points I have covered now? So all that points are taken from the different books. So that references I have shown here. Okay, VK Jain sir's book, that is advanced machining processes, then non-conventional machining by PK Mishra, unconventional machining process by T Jagdesha. So all the books are available in hard copy in our institute level or our central library. You can take that books afterwards, no problem. Okay, and already the same lecture, okay, today morning itself I have released it through the my YouTube okay premiere. So if you have missed or if you have not understand any point about the our third chapter or what are the chapter 1, 2, 3, you can watch the lectures. Okay, just at YouTube you can just write hash DT Kashit, Professor DT Kashit. Okay, without space you will get the all the videos link. Okay, there itself. At YouTube you can write hash Professor PROF DT without space. Okay, continue your track. Then immediately you will get the all the videos. Okay, so this is about the our third chapter. Okay, from my side, I have completed all the points as per our syllabus. If anybody have any problem, then you can ask me any problem, any suggestion, any query from your side. If yes, then ask me. If no, then give me permission for the further part. Okay, may I proceed for further part?
Yes, sir.
Okay, so in the next lecture, maybe tomorrow, day after tomorrow, we'll start the our section second, that is a chemical energy based processes. Okay, so I think we have not gone for the quizzes for the chapter number 2. Okay, so for that already I have created or I have generated the quizzes. The quiz link I will post here now in the chat box as well as in our at our WhatsApp group. Okay, you can solve later on or immediately, no problem. I have given the time limit up to tomorrow 3 p.m. No problem. Okay, so up to that you can solve two times or a single time, no problem. Okay, for practice purpose you can go for twice also, no problem. Okay, now wait, I will share that link here as well as in the chat box. Please don't leave this group because I have to take the attendance also. So just I have shared the link in the chat box as well as in our WhatsApp group. So up to tomorrow 3 p.m. you can attend that, no problem. Okay. Now wait for 2 minutes only. Immediately I will take the attendance from your name. Okay. Don't leave this or this meeting. 16. No need to give your attendance in the chat box. Okay. From your name itself, I am writing your roll number. जाऊ लगेच आपण. होय, गेलं वाटतं वातावरण जरा झालं. काय करायला
मी करा म्हणत होतो मी आज 18-19 आरवर रविवारी येऊन गेले. 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 26, 27.
फक्त 27 जण जायचं काय? कोण राहिला का B12 त्यातला? या खतर 15. Okay, I will post attendance in the WhatsApp group also. If anybody uh, left before this attendance, they can mention they can mention their roll number in the group also. Okay, so thank you very much. Here we will stop today's lecture.